Hey guys, Mr. Riz here to help you out for the 3.7 review worksheet. So your review or your quiz will actually have three questions similar to this one. So just make sure you guys understand how to do these problems really well. You kind of know the ins and outs. So a management of a large store has 1,600 feet of fencing to fence a rectangular storage yard using the side of the building and the yard. If the fencing is used for the remaining three sides, find the length, width, and the area of the largest possible yard. So I guess they have a big building here. They're going to put some fencing this way and that way and then this way. So they're going to use the side of the building to contain this yard. Okay, so we have a nice rectangle here, an X by Y rectangle that we are trying to maximize. All right, we can't just go through and take the derivative, so we need to look at our constraint. The constraint is that we have 1,600 feet of fencing. So that means that 2x, because we have one here and one here, plus the 1y would have to equal 1,600. Now we can use some just math here by subtracting the 2x over and say 1,600 minus 2x would equal y. So that's something we can go through and substitute into our area equation. The area would be x times 1,600 minus 2x. Or in other words here, if we distribute the x, that it is 1,600x minus 2x squared. Okay, so if we want to maximize a problem, any equation, we need to take the derivative of it and set it equal to 0. So what is the derivative of that? The derivative of 1,600x is 1,600. The derivative of minus 2x squared is minus 4x. So we're going to set that equal to 0 to figure out what that is. All right, I'm going to move the 4x over to the other side. So 1,600 equals 4x. And divide by 4, so that means x would equal 400. Okay, so it does say find the length, the width, and the area. And those are all underlined. So let's make sure we understand what those all are. Well, the width is kind of easy because I would say that the width is this segment here. All right, and so that's equal to x, and x is 400. The length here, we have to plug it back in here. Okay, so what's 1,600 minus 2 times 400? All right, so what's 1,600 minus 800? Well, that'd be 800. And then the area would be, well, this is 400, this is 800, whatever 400 times 800 is, and 4 times 8 is 32, and then we got 0, 0, 0, 0. So 320,000 square feet would be the largest possible area they can enclose. Okay, let's check the next problem out. So remember, anytime you guys can pause, rewatch these videos and go through. So an open box is made from a rectangular piece of cardboard that is 7 inches by 3 inches. I'm going to go through and just kind of give us a little bit more room here. By cutting equal squares off the corners. Okay, so we kind of did this before. What we are going to do here is we got a 7 by 3 inch square. We're going to take off this corner here and those corners there. We're going to cut off these corners. They're all going to be the same square, so x by x squared. All right, and then we're going to take these edges here that are left over. We're going to fold them up. So we're going to make like a open box that looks like that, where they'd be x tall. And then we can find out the sides here. So the one long side would be, well, it would be 7, but minus 2x's on both sides. And then this front here would be 3, but minus 2x. Okay, so our volume formula is the length times the width times the height. And what we want to do now is just substitute that in with our variables that we figured out. So the length, I would say, is 7 minus 2x. The width would be 3 minus 2x. And then height would just be straight up x. Okay, so before we take the derivative, let's distribute this all out. Let's see what we got. All right, 7 times 3 is, we got 21, and then times by the x. All right, 7 times 2 is negative 14, but we'll make that x squared, is the x. Negative 2 times 3, that's negative 6. We'll make that x squared. And then negative 2 times negative 2 is positive 4, and we'll make that x cubed. All right. So the volume formula here, it takes a lot longer to do this, but we'll put it out first. We got 4x cubed. We would have, let's see, over here, we could add those together. That's minus 20x squared and then plus 21x. Okay, so this is the formula. If we just plug in any number for our x, our height, we could determine the whole volume of this. What we want to do now is let's go through and find the maximum, and any maximum point is a critical point on the first derivative. So we take the derivative here. 4x cubed goes to 12x squared. Minus 20x becomes minus 40x, and the plus 21x becomes plus 21. Okay, we're going to set that equal to 0. Now, we could see if that factors. I don't think it does, so we got to use the quadratic formula. So x equals negative b, so that's 40, plus or minus the square root of 40 squared is 1600 minus 4 times 12, is a, 21 is c, all over 2 times a, so that's 24. Man, this is going to be lovely. Luckily, we have a calculator here to make our life easier. We got 40 plus or minus the square root of. All right, what is 1600 minus 4 times 12 times 21? That'd be 592. All right, I don't think the square root of 592 comes out nice. It doesn't, so we're going to get some decimal answers. We're going to get 2 of them. One's going to be 40 plus the square root of 592. So just typing that into the calculator, and then we divide that by 24. We get 2.68. And then we're also going to do 40 minus that. So 40 minus the square root of 592. Press enter, then divide that by 24. We get 0.65. Okay, so we got 2 answers here. So we're going to go through and see which one makes sense. Now, technically, we probably should plug them both in and compare the volumes, but you can kind of think about this and make sense. If x was, 2.8 inches wide, and this side is 3 inches, so how could we take 2 of those away if both of them almost go all the way across? So we can cross that one off. That one doesn't work. The only answer that would work, that would make an actual volume, is 0.65. So let's talk about what's the length, what's the width, what's the height, and then what's the maximum volume. So we got to start plugging these in here, making sure we know. The height is easy. The height is x. So we'd say the height is 0.65. No, I mean, actually, it's like 0.6528729112, but we get close enough here. All right, what's the length? Well, we'll just go ahead in the calculator. What's 7 minus 2 times 0.65? We get 5.7. And then what's the width? What's 3 minus 2 times 0.65? I get 1.7. And then the volume, all we need to do is just what's the length times the width times the height. So we'll times those numbers together. Now these are just a rounded decimal, so this isn't entirely accurate, but it's going to be close enough. So the maximum volume is going to be pretty darn close to about it says 2985 on my calculator, so I'm going to say 6.3, and this would be cubic inches. Okay. All right, last problem here. Let's see. A closed cylinder is to have a volume of 300 pi cubic inches. The material on the top of the bottom. Okay, so let's draw a cylinder out. All right, and a cylinder is, we got a radius and a height. Okay, we know that the volume of that is pi r squared h, and it does say it has to have 300 pi inches. Okay. The other thing that we know here is that the cost here of the top and bottom is $2 for the top and then $6 for the side. All right, draw and label the pillar. Now write down the problem that would be the lowest dimension. Okay, so let's talk about the cost. The cost is a surface area problem, but multiplying by the height. So the surface area, we got 2 of these circles. So each circle, we got pi r squared for the circle. We times it by 2 because we have a top and bottom, and then we times it by 2 because it's $2 for the top or bottom. So here's a circle, we got a top and a bottom, and they cost $2 each. So All right, so there's the formula for the top, and then we got to add the sides. The side is a like rectangle where we have the circumference 2 pi r, and then we're going to times it by the height h, and there's only the one of them that wraps around. We'll times that by 6. Okay, so this is the problem for the for the cost. We have radius and height. So if we can change this height from this constraint here, we can make this equation all in terms of r. So the nice thing about this here, we can divide by pi r squared. So h would equal 300 pi divided by pi r squared. And so, okay, h would equal 300 over r squared. So let's write this out. The cost would equal, all right, so 2 times 2, this would be 4 pi r squared, and then plus whatever 2 pi r times 300 over r squared times 6 is. Okay, so this would be 4 pi r squared. Okay, what do we got here? What's 2 times 300? That'd be 600. Times 6, that'd be 3,600. And then pi. And if we times by r, but then divide by r squared, that'd be dividing by r. So we're going to put r to the negative 1 power. Okay, so this is the formula that we're going to take the derivative of. So let's minimize the cost. All right, the derivative of 4 pi times 2, that'd be 8 pi. Drop r down to the first degree. All right, 3,600 pi times negative 1 is negative 3,600 pi. And then drop down to r squared. So we kind of want to know here, one does 8 pi r minus 3,600 pi over r squared, because that's what the, oh, that should be the negative 2 power, yep. Okay. Negative 1, drop down to negative 2, equals 0. Okay, so we can move that over to the other side, and one does 8 pi r equal 3,600 pi over r squared. We can cross multiply, and we would get, let's see, 8 pi r cubed equals 3,600 pi. So pi has been kind of sticking around making this problem look ugly, but they cancel each other out. All right, we'll divide by 8. What's 3,600 divided by 8? Probably could do that in my head, but I don't want to right now. 450. And then we're going to take the cube root. Now, it probably doesn't come out nicely. So what's the cube root? What's 450 to the 1/3 power? That is, of course, 7.66. It doesn't come out nice. All right, so it does say find the dimensions. So we do need to, and I'm going to just write up here when I have a little bit more room. The dimensions, we just need to know what's the radius and what's the height. Does it say find the cost? I guess we could go through and plug it back in to find the cost as well. But let's just find the radius and the height. The radius is 7.66, and the height would be, well, 300 divided by that number squared. All right, so if we square that number and then do 300 divided by it in our calculator, we get about 5.11. All right, there we go. Okay, so this is what your quiz is going to look like. I think you guys will be all right on this. You do the review, spend some time, make sure you kind of know what to look out for. All right, guys, so this actually wraps up chapter 3, and then chapter 4, we start working backwards with antiderivatives. Have a great day. I'll see you next time.